Number 14. What is the volume of the rectangular prism? Volume of a rectangular prism is length times width times height. Volume means the space on the inside. Length is going to be the larger of the two that are on the base. Height is the one that goes up. And then width is going to be the smaller of the two on the base. Base is the bottom. I plug the numbers in. Volume is equal to this. Since this is multiply, we do our math left to right. And we get exactly the right answer. Number 15. Okay. Fill in the blanks, and we're asked to use available answer choices. Use the solid figure. They want us to determine whether each statement is true or false. Okay. Now, I have a few issues with this one, so I'll go and address those as we go through. So, it's a lot of vocabulary here, so it's analyzing the vocabulary and going through each one. Polyhedron is a three-dimensional shape with no curves. That's the easiest way for me to think about it. So do you see any curves on this shape? No, so it is a polyhedron. It's like flat edges, flat planes for sides, that kind of stuff. It has 5 faces. A face is a plane. So we have the dark plane right here, 1, the next plane, the triangle, 2, the bottom 3, the front and the back, 4, 5. 5 is correct. The base of the rectangle. Usually, and this is where I start having some issues, usually the base would be the one on the bottom. Okay, usually the base is what's on the bottom, base or bottom. But when we're looking, and that's one of the particulars about this triangular prism, is this triangle would be the base because of the type of shape it is. The base, this triangle, extends all the way to the other side. And that's kind of what makes it. The base would usually be what's on the bottom, but in this case, it's the triangle because of the type of shape it is. So it's a special circumstance here. And that's where my note is. It's easier to calculate this volume idea when you look at it as a triangle base. The lateral faces are rectangles. Okay, so a lateral face are the faces that are not the base. So if we're assuming the base is this triangle, and this triangle right here is kind of an extension of that base, then it's these sides are the lateral faces, and those are rectangles. There are 6 vertices. Vertice is another name for corner. It's where 2 edges meet. And how many vertices, how many corners do we have? 1, 2, 3, and then 4, 5, 6. Total of 6. Check. How many faces do we have? Do we have 6? Edges. How many edges do we have? So just kind of trying to be mathematical about it. We have the 3 from the triangle. Those reflected on the other end is another 3. That makes 6. And then we have the connectors, 7, 8, 9. So in this one, we have 9 edges. Number 16. Sunny Beaches is a company that designs and makes beach balls. The beach ball shown has a radius of 8 inches. Determine the volume of the ball in cubic inches. They're asking us to approximate pi with 3.14 and then round to the nearest hundredth if necessary. And remember, our rule for rounding is we round at the end of the problem. In this case, we can plug in this approximation as soon as we need to. I always recommend calculating all the math first before you plug it in, and then it's kind of like doing it at the end of the problem anyway. And then they're asking, here's the volume. So we need volume of a sphere. A ball is a sphere. So the volume of a sphere is 4/3 pi r cubed. The radius is 8. So we plug that radius in. Radius is 8. And exponents come first. 8 cubed is 512. Then we do the multiply. So times 4/3. I got this right here. And then now and notice I kept my pi the whole time. Now we plug the 3.14 in. That's what it told us to do. Use 3.14 for pi. And so I get this. And then round to the nearest hundredth. Hundredth is tenths, hundredths, thousandths. So the second place after the decimal is the hundredths place. We look to the next one to the right. 4 or less means it truncates or gets cut off. 5 or higher means it rounds up. So this is a 3, so everything just drops off right there, and there's our final answer. All right. Number 17. What figure can be formed by this net? Net is a two-dimensional representation of a 3D shape that's been broken down. So if you pull these two triangles up and connect them with these rectangles, you would get this shape right here. This comes from experience. There's no easy way. We just have to practice the types of shapes and get used to them. And then same thing for these, getting used to the vocabulary. This shape matches the triangular prism vocabulary. We had a triangular prism a few problems ago. Same thing for the next one. It's either you have the ability to see it or you don't through experience and practice. Match each image with its correct view of the figure. Gray segments indicate breaks. Okay, or like to me, a gray segment would be like a different depth to it. So which one's the front, left, top, or right view? For this shape, if we're looking at it from, and they have to tell you, otherwise it's arbitrary, what the front is. So here's the front, looking at it from this way, and that would match here. So it kind of steps to have this, it's kind of like a shadow, right? Shadow, if the sun or the light source is coming from the front, it's going to make kind of a similar shadow to that. This would be a top view. So looking straight down on the top, that would be the representation of the top. From the left view, from this left side right here, it just looks like an L. That's all you see. There's no depth to it. And then the right side, looking at it from this way, then we do have some different depths, and that's why they have the different gray going on those. This one you have to visualize. Use your imagination. You can't really draw it or do anything else other than get used to the technique of trying to see what it looks like from different angles. Fill in the blanks again. We're using available answer sources, so we need to use those answers. The net, so that's that two-dimensional representation of this shape, of this solid, would include, so how many squares would we see here? I'll go ahead and break it down with my solution. So when we look at it, we would see one square on the bottom here. There's a 48 and 48. So that net will have a square for the bottom. Blank rectangles. So the rectangles would be this one, right side, front side, left side, back side. Those are all rectangles. There's 4 of those. And how many triangles? So same thing, the right side, front side, left side, and back side have the 4 triangles. If we're doing volume, we'd have to do it separately with the triangular or the square pyramid and the cube. Number 20, the difference between accurate and precise. Accurate and precise. Golfers, their last 5 drives match each description with its correct image. All right. So accurate. Accurate means you're hitting the target or you're close to the target. If you have accuracy, you're hitting the bullseye. You're accurate. Precise means they're grouped together. It's kind of like if doing target practice and the paintball is all of them, the gun hasn't moved, the paintball gun hasn't moved, but all of them are located and grouped together in a spot, not necessarily on the target. So it's the paintball gun would be precise, but we just need to change the accuracy on it, okay, or change the targeting on it. All right. Grouped together for precise, close to the target. So these are all scattered around and none of them close, so that would be not accurate, not precise. This one, they're around the target, but they're not grouped tightly together. So they're around the target, that's accurate, but it's not precise. So once again, kind of think about the paintball gun, and it's not hitting the target, but you're aiming right at it. Okay. This one is both accurate and precise, so they're located close to the hole, and they're all grouped close together. And then this one right here, notice they're grouped close together, but they're not at the target. So that would be precise. They're grouped together, but they're not accurate. Okay. Number 21. Nico told his friends he was 72 inches tall. However, he visited a doctor to be measured. He was actually 47.125 inches tall. What is the approximate error in his height? The approximate error is in inches. Okay. Approximate error is going to be the actual minus the estimate. And sometimes it's an absolute value. According to my research, we can go positive or negative or be an absolute value idea. So the actual is 47.125. We subtract the estimate, which was 72, and we get an error of 2.125, and then the context is inches. (22) Sonja is putting new tile in her kitchen. She measures her kitchen to be 12 feet by 18 feet. The tile she chose is $2.60 per square foot. What is the range of the actual cost of tiling the kitchen? Okay, so be careful. They're not looking for the actual amount. This would be the actual amount right here, length times width, and then multiply it by the cost per square foot. But they want the range. So the range is, now normally I would think of about rounding. If it were 12.5, it would got rounded up to 13. So, but in this context, their range goes to 12.5. Mathematically, it would be a 4 that would round down. If this were 18.5, that would be a 19. But mathematically, in this context, we're making those 5s here. Okay, so that's for this book. So we have to conform to what they're giving us here. So the bottom range would be, so notice the 12 feet, we have a bottom of an 11.5 and a 12.5. So I think their strategy basically is we're trying to make it the same amount, 0.5 in both directions. Same thing for the 18.5 in both directions. So the lower or bottom range will be the 11.5 times the 17.5, and then the price was $2.60. And that gives us the 523.25. The top range, I tried to do the 0.4s. That doesn't work. It gets pretty close, but the proper way of doing it is, like I said, they want those 0.5s at the end. So the top part of the range, the 12.5 times the 18.5 times the price, and then that links together and gives us our solution. Significant digits. There's a whole structure of how significant digits are. I'll just go through the answers they have to focus on what's most important at this time, giving you a start. All right. So significant digits is used in science, and the leading zero, a zero in front, never counts. So the leading zero, a zero in front, never counts. So we have a zero here. This one's not going to count. So there's only the two digits, the 3 and the 1. That's 2. There's no decimal here. A decimal matters when we have it behind us. So if there were a decimal here, this would be 5 digits. But since there's no decimal, it's just the 2 digits. These are called trailing zeros. Trailing zeros do count. So leading zeros don't count. Trailing zeros do count. All right, so if there's a decimal, we count the trailing zeros. So right here, no problem. It's just 3.25. The zeros are what makes this tricky. 3 digits here, pretty straightforward. And then 3 digits here because there's no decimal. If there were a decimal, this would have 5 digits, but there's no decimal. Here's a decimal here, so here's a good example. A trailing zero, a zero at the end, does count if we have a decimal. There's our decimal, so we count that 0. Even though it's at the end, mathematically we would drop it, but significant digits means it's important. The next one, we have a 0 in the middle. We'd definitely count zeros in the middle. Let's count. And then this one here, we basically like a 0 in the middle, 5 digits. Okay. Yvonne measured a caterpillar to be 3.5 inches long. Explain how to find the possible range for the length of the caterpillar using correct number of significant figures. All right. So when we're actually using it in measurement, basically we're looking at how many decimal places we have. We have 1 decimal place, so that's the one that they would call uncertain. This is uncertain to 1 decimal place. All right, but that's basically the one that we would want to use. Okay, so we'd want to have 1 decimal place on this one. We look here and we have 3, and this goes halfway to the next one. So be careful. This is not by tenths, but 1, 2, 3, 4, 5, 6, 7, 8. So it goes by eighths to each of the next inches. So this is 4 eighths right here. So that's a 3.5 where they're getting it. Okay. So 3.5 with significant figures. There are 2 significant figures here. Since this is the 0.5, it's halfway between. They're calling that the uncertain about 1 decimal place. So that's why they have it right here. It's kind of what they gave you, and then you go off of that. So they gave us the 3.5. It's uncertain to 1 decimal place, and there are 2 significant digits. Last one. 25. True or false? When considering rounding with significant figures, we have the area of the rectangle is rounded to 22 square centimeters. Is that true or false? So the idea here again is that this problem and this problem both have one uncertain digit and there are two significant figures to each one. So we'd have to calculate the length with using that to tell us how to round. So we have one significant figure here, or one uncertain figure here, one uncertain figure here. That means our answer is going to round to the one significant figure. So we're rounding, it's rounding to the tenths place, basically. Okay, so we'd go ahead and calculate it, do it just like they've given us. Here's the answer, and then I'm rounding to the tenths place. So I look at the 6 to round. The 6 is 5 or greater. That means the 9 rounds up, and then that drops off. So 22 is our answer. We always make it a little bit less than what they give us in the original problem. And that's the last one.